Friends, welcome to my channel. Dhanesh here. A/B testing is a popular way to test your products and is gaining steam in the data science field. Here, we shall understand what A/B testing and how you can leverage A/B testing in data science using Python. Picture this scenario. You have made certain changes to your website recently. Unfortunately, you have no way of knowing with full accuracy how the next 1 lakh people who visit your website will behave. That is the information we cannot know today. And if we were to wait until those 1 lakh people visited our site, it would be too late to optimize their experience. This seems to be a classic catch 22 situation. This is where a data scientist can take control. A data scientist collects and studies the data available to help optimize the website for a better consumer experience. And for this, it is imperative to know how to use various statistical tools, especially the concept of A/B testing. A/B testing is a widely used concept in most industries nowadays, and data scientists are at the forefront of implementing it. In this video, I will explain A/B testing in depth and how a data scientist can leverage to suggest changes in a product. So the portions we are covering here: what is A/B testing? How does A/B testing work? Statistical significance of the test. Mistakes we must avoid while conducting the A/B test. When to use A/B test. What is A/B testing? A/B testing is a basic randomized control experiment. It is a way to compare the two versions of a variable to find out which performs better in a controlled environment. For instance, let's say you own a company and want to increase the sales of your product. Here, either you can use random experiments or you can apply scientific and statistical methods. A/B testing is one of the most prominent and widely used statistical tools. In the above scenario, you may divide the products into two parts, A and B. Here, A will remain unchanged while you make significant changes in B's packaging. Now, on the basis of the response from customer groups who used who used A and B respectively, you try to decide which is performing better. In a hypothetical testing methodology for making decisions that estimate population parameters based on sample statistics, the population refers to all the customers buying your product, while the sample refers to the number of customers that participated in the test. How does A/B testing work? In this video, let us understand through an example the logic and methodology behind the concept of A/B testing. Let's say there is an e-commerce company XYZ. It wants to make some changes in its newsletter a newsletter format to increase the traffic on its website. It takes the original newsletter and makes it A and makes some changes in the language of A and calls it B. Both newsletters are otherwise same in color, headlines, and format. Let's discuss the objective. Our objective here is to check which newsletter brings higher traffic on the website. That is the conversion rate. We will use A/B testing and collect the data to analyze which newsletter performs better. So, make a hypothesis. Before making a hypothesis, let's first understand what is a hypothesis. A hypothesis is a tentative insight into the natural world, a concept that is not yet verified, but if true, would explain certain facts or phenomena. It is an educated guess about something in the world around you. It should be testable either by experiment or by observation. In our example, the hypothesis can be by making changes in the language of the newsletter, we can get more traffic on the website. In hypothesis testing, we have to make two hypotheses. That is the null hypothesis and alternative hypothesis. Let's take a look at both. Null hypothesis or H0. The null hypothesis is the one that states that sample observation results purely from chance. From an A/B test perspective, the null hypothesis states that there is no difference between the control and variant groups. It states that the default position to be tested or the situation as it's now, that is the status quo. Here, our H0 is there is no difference in the conversion rate in customers receiving newsletter A and B. Alternative hypothesis. The alternative hypothesis challenges the null hypothesis and is basically a hypothesis that the researcher believes to be true. The alternative hypothesis is what you might hope that your A/B test will prove to be true. In our example, H0, the conversion rate of newsletter B is higher than those who receive newsletter A. Now we have to collect enough evidence through our test to reject the null hypothesis. Next, create control group and test group. Once we are ready with our null and alternative hypothesis, the next step is to decide the group of customers that will participate in the test. Here we have two groups, the control group and the test or variant group. The control group is the one that will receive newsletter A and test group is the one that will receive newsletter B. For this experiment, we randomly select 1000 customers, 500 each of our control group and test group. Randomly selecting the sample from the population is called random sampling. It is a technique where each sample in a population has an equal chance of being chosen. Random sampling is important in hypothesis testing because it eliminates sampling bias. And it is important to eliminate bias because you want the results of your A/B test to be representative of the entire population rather than the sample itself. Another important aspect we must of take care of is the sample size. It is required that we determine the minimum sample size for our A/B test before conducting it so that we can eliminate under coverage bias. It is the bias from sampling too few observations. Conduct the A/B test and collect the data. One way to perform the test is to calculate daily conversion rates for both the treatment and control groups. Since the conversion rate in a group on a certain day represents a single data point, the sample size is actually the number of days. Thus, we will be testing the difference between the mean of daily conversion rates in each group across the testing period. When we run our experiment for 1 month, we notice that mean conversion rate for control group is 16%, whereas that for the test group is 19%. Next is the statistical significance of the test. Now, the main question is, can we conclude from here that the test group is working better than control group? The answer to this is simple no. For rejecting our null hypothesis, we have to prove the statistical significance of our test. There are two types of errors that may occur in our hypothesis testing. Type 1 error, we reject the null hypothesis when it is true. That is, we accept the variant B when it is not performing better than A. Type 2 error, we failed to reject the null hypothesis when it is false. It means we conclude variant B is not good when it performs better than A. To avoid these errors, we must calculate the statistical significance of our test. An experiment is considered to be statistically significant when we have enough evidence to prove that the results we see in this sample also exist in the population. That means the difference between your control version and test version is not due to some error or random chance. To prove the statistical significance of our experiment, we can use a two-sample t-test. The two-sample t-test is one of the most commonly used hypothesis tests. It is applied to compare whether the average difference between the two groups. To understand the statistical significance, we must be familiar with the few terms, that is significance level alpha. The significance level, also denoted as alpha, or alpha is the probability of rejecting the null hypothesis when it is true. Generally, we use significance value of 0.05. P-value, it is the probability that the difference between the two values is just because of random chance. P-value is evidence against the null hypothesis. The smaller the p-value, stronger the chance to reject the H0. For the significance level of 0.05, if the p-value is lesser than it, hence we can reject the null hypothesis. Confidence level. The confidence interval is an observed range in which a given percentage of test outcomes fall. We manually select our desired confidence level at the beginning of our test. Generally, we take a 95% confidence interval. Next, we can calculate our t statistics using the below formula. T statistic is equal to observed value minus hypothesized value divided by standard error. Standard error is equal to root of 2 variance of sample divided by n. Let's implement the significance test in Python. Let's see a Python implementation of the significance test. Here we have a dummy data having an experiment result of an A/B testing for 30 days. We will run a two-sample t-test on the data using Python to ensure the statistical significance of data. You can download the sample data here. Let's plot the distribution of target and control group. At last, we will perform the t-test. For our example, the observed value, that is mean of the test group, is 0.19. The hypothesized value mean of the control group is 0.16. For the calculation of the t-score, we get the t-score as 0.3787 and the p-value is 0.00036. So what does all this mean for our A-B testing? Sorry. Here our p-value is less than the significance level, that is 0.05. Hence we can reject the null hypothesis. This means that in our A-B testing, newsletter B is performing better than newsletter A. So our recommendation sorry we would be to replace our current newsletter with B to bring more traffic on our website. What mistakes should we avoid while conducting A/B testing? There are few key mistakes I have seen data science professionals making. Let me clarify them for you here. Invalid hypothesis. The whole experiment depends on one thing, that is the hypothesis. What should be changed? Why should it be changed? What the expected outcome is, and so on. If you start with the wrong hypothesis, the probability of the test succeeding decreases. Testing too many elements together. Industry experts caution against running too many tests at the same time. Testing too many elements together makes it difficult to pinpoint which element influenced the success or failure. Thus, prioritization of tests is indispensable for successful A/B testing. Ignoring statistical significance. It doesn't matter what you feel about the test, irrespective of everything, whether the test succeeds or fails. Allow it to run through the entire course so that it reaches the statistical significance. Not considering the external factor, tests should be run on comparable periods to produce meaningful results. For example, it is unfair to compare the website traffic on the days when when it gets the highest traffic to the days when it witnesses the lowest traffic because of external factors such as sale or holidays. When should we use A/B testing? A/B testing works best when testing incremental changes such as UX changes, new features, ranking, and page load times. Here you may compare pre and post modification results to decide whether the changes are working as desired or not. A/B testing doesn't work well when testing major changes like new products, new branding, or comparatively new user experience. In these cases, there may be effects that drive higher than normal engagement or emotional responses that may cause users to behave in a different manner. To summarize, A/B testing is at least 100-year-old statistical methodology, but in its current form, it comes in the 1990s. Now it has become more eminent with the online environment and the availability for big data. It is easier for companies to conduct the test and utilize the results for better user experience and performance. There are many tools available for conducting A/B testing, but being a data scientist, you must understand the factors working behind it. Also, you must aware of the statistics in order to validate the test and prove its statistical significance. Thanks for watching. Please like, share, and subscribe. Thanks a lot.